Hi, this video covers section 10.3 of Introductory Statistics in OpenStax. It is talking about the two hypothesis testing for two independent population proportion. In chapter 9, we talked about the hypothesis testing for population proportion when we had one sample. And if you remember, we had P, which is the population proportion, P hat, the sample proportion, n, which is the sample size, x is the number of success. So in this case, since we have two populations and we have two samples, so we have two out of each of those notation. So we have P1 and P2 that are showing the first population proportion and second population proportion. We have N1 and N2, which are the size of the first and the second sample. X1 and X2, which are the number of success in the first sample and the second sample. P hat 1 and P hat 2, which are the sample proportion, the first sample proportion and the second sample proportion. And you know, every time we have a P, the Q is always 1 minus P. If we have P1, Q1 is 1 minus P1. P2, Q2 is 1 minus P2. If we have P hat 1, Q hat 1 is 1 minus P hat 1, because P and Q are the complement of each other. After learning about the notation, now we want to start a hypothesis test. Since in any hypothesis test, in the null hypothesis, we always assume that the population proportions are the same, the sample proportions are the population proportions are the same. It means P1 is equal to P2. So, but we don't want to assume, to read that the two samples have a different proportion. We find the pooled estimate proportion. The pooled estimate proportion, which we show by P bar, it's kind of combining the two proportion. And how we find the P bar, the pooled estimate proportion, by just adding x1 and x2 for the numerator and adding n1 and n2 for the denominator, because you know that the P is always x over n. When we have P bar is x1 plus x2, we are combining the two proportions and we call it the pooled estimate proportion. And we use a pooled estimate proportion instead of using P hat 1 and P hat 2 or P1 and P2. And Q bar, again, is always 1 minus P bar. After finding the pooled estimate proportion, like any other hypothesis test, we need to check the requirement. And when you check the requirement tells you that first, this samples must be random. The second requirement says that the samples must be independent. These two requirements are exactly the same as the requirement when we working on a hypothesis test for population mean. And the third requirement is that we have to have at least 5 successes and 5 failures. That means X must be a number more than 5. Or instead of X, we can say N times P and N times Q must be more than 5. But this time we have two populations. We have two samples. It means that N1 P hat 1, N1 Q hat 1, N2 P hat 2, N2 Q hat 2, all of them must be more than 5. Or instead of using P hat 1 and P hat Q hat 1, instead of using P hat 2 or Q hat 2, we can use the pooled estimate. We can say N1 P bar and N1 Q bar, both of them must be more than 5 for the first sample. And for the second sample also, N2 P hat 1, N2 P bar and N2 Q bar, both must be more than 5. We have to make sure that we have at least 5 successes. We can find P bar and Q bar, multiply by N1, the first sample size and the second sample size, and after we make sure that all of them are more than 5, it means that the problem meets all the requirements. But you know that we have a normal distribution, and in any normal distribution, we need the mean and the standard deviation. So what's the mean and what's the standard deviation when we talk about the population proportion? When we talk about the population proportion, the mean is P bar minus P2, the difference between the proportion. And the sigma is coming from this form. So we can say that we have a random variable. This one is our variable. The mean is P bar minus P2, and the standard deviation is the square root of P bar Q bar 1 over N1 plus 1 over N2. And if it's a standard normal distribution, since we always assume P bar is equal to P2, P bar minus P2 is always 0. Like mu1 minus mu2, which is always equal to 0. P bar minus P2 is also equal to 0. So remember, if they ask you to write the function, you need the mu and the standard deviation, which both of them are coming from these formulas. So let's start a hypothesis test. So in any hypothesis test, after checking the requirement, now we need to find the test statistic. We check the requirement, we write the null and alternative hypothesis, then we need to find the test statistic. And the test statistic is coming from this formula. So in chapter 9, we said whenever we work with the population proportion, we need to use z-test. Again, we're going to use z-test. In chapter 9, we had only one sample. So the formula was p hat minus p over the square root of p times q over n. In this section, since we have two population and two samples, we have p hat 1 minus p hat 2 instead of just one p hat. We have p1 minus p2 instead of just having a p. And at the denominator, we have p bar and q bar instead of p and q, but instead of 1 over n, we have 1 over n1 plus 1 over n2. And you know that the p bar is the pooled estimate proportion, which coming from this formula. And after finding the test statistic, you have two different methods to solve the problem. You can use the rejection region method, or you can use the p-value method. So all the steps of the hypothesis test are the same, except the formula that we need to use for z, for the test statistic, which is this formula. So again, we are following same steps for a hypothesis test. And these are the formulas and the function that we need to use if you are using the TI-83 or 84 calculator. But I want to work on the next 2 or 3 problems manually. But you can still use TI-83 or 84 calculators. And in the last example, I will show you how you can use online calculator as well. So let's look at the first example. The first example, it says a study of 200 randomly selected people driving vehicles in Washington and 250 randomly selected people driving vehicles in Vermont shows that 93% of people driving vehicles in Washington and 88.8% of people driving vehicles in Vermont wear seatbelts while driving. And you know, whenever the problem gives you a percentage, it tells you that this problem is about the proportion. Okay, it says if alpha is 10%, can you reject the claim that, okay, let's see what's the claim. The proportion of people who wear seatbelt y deriving is the same for Washington and Vermont. Okay? And the information from the two samples are given in this table. So for a full hypothesis test, first we need to check the requirement. The requirement tells me that the samples must be random. Okay, samples are random. The samples must be independent. They are independent because they are from two different states. And we have to have at least 5 success or 5 failure. And as you see, x1 and x2, both of them are numbers more than 5. They are more than 5. But we can still check that requirement to make sure by finding the pooled estimate proportion. The pooled estimate proportion is P bar. And P bar is x1 plus x2 over n1 plus n2, which is 186 plus 222 divided by 200 plus 250. And after finding the P bar, we need to multiply n1 by P bar and n2 by P bar. And the same for Q bar, because Q bar is 1 minus P bar. After finding these values, we need to multiply n1 by Q bar and 2 by Q bar and make sure that all of them are greater than or equal to 5. And you can see all of the results here. The pooled estimate is 0.09. So the Q bar is 1 minus that, which is 0.0933. And if I multiply n1 by P bar, n1 by Q bar, n2 by P bar, and 2 by Q bar, you will see that all of those are greater than 5. So you check the requirement. Now, next step is writing the null and alternative hypothesis. To write the null and alternative hypothesis, you need to look at the claim. The claim says that the proportion of the people in these two states are the same. So proportion means P, P1 and P2, P1 and P2. When it says the proportions are the same, that means P1 must be equal to P2. And we always put the equal sign for the null hypothesis. If null hypothesis is equal, that means the other one is not equal to. And we know that the claim is on the null hypothesis in this case. Then we are going to follow the rejection region method. You can work with the p-value method, but I am going to do the rejection region method. If you are using the rejection region method, that means you need to find the critical values from Z table and then find the test statistic and check if the test statistic falls in the rejection. By looking at the alternative hypothesis, you know that you have a two-tail test, which it means you have two critical values, one positive, one negative. How we can find these values? By looking at the Z table. The alpha is 10%. That means half of the alpha is on the right and half of the alpha is on the left. If I open the Z table and look at the body of the table, try to find 0.05, it tells me that what Z value corresponds to that area. So let's look at the Z table and try to find 0.05. So 0.05, let's see where that is. I think it's somewhere between these two. Which means we have to find a number between these two, negative 1.64 and negative 1.65. And the number that's in the middle is negative 1.645. So the critical values are negative 1.645 and positive 1.645. And after finding the critical values, I know that the rejection region method are the shaded area. And the shaded area are the z values that are less than negative and more than the positive. So the rejection region are all the z values that are less than negative 1.645 and more than positive 1.64. Okay, now, after finding the rejection region, it's time to find the test statistic. We write the formula and plug in numbers for all of this notation. And you always know that the P1 minus P2 is always 0 because we assume that P1 is equal to P2 in the null hypothesis. So we only need to replace numbers for P hat 1 and P hat 2, for P bar and Q bar, which we already calculate them, N1 and N2. And you see that the number that we get is 1.52. Now the question, is 1.52 in the rejection region? Rejection region tells me it has to be more than 1.6. But is this number more than 1.6? No. And if you look at the picture, you will see that the number is not in the rejection region, is not in the shaded area. And if it's not in the shaded area, we fail to reject the null. If we fail to reject the null, if you look at the null and alternative hypothesis, if you fail to reject the null, that means you reject the alternative. And the claim is on the null. And you cannot reject the claim. So what do we say? When the claim is on the null, we have to use the word reject, and we are not going to reject the claim. So we say there is not enough evidence to reject at 10% level of significance to reject the claim. That the proportion of people who wear seatbelts while driving is the same for those two states. Now let's look at next example. So feel free to pause the video, work on the problem, and check your work after I go over the answers. The question says, a medical research team conducted a study to test the effect of a medication to treat patients with post-traumatic stress disorder. At the end of the study, the researcher found that 42 randomly selected subjects who took the medication, 28 no longer met the diagnostic criteria for PTSD. But out of the 37 randomly selected subjects who took a placebo, 12 no longer met the diagnostic criteria for PTSD. So if you remember in chapter 1, we talked about the treatment and placebo. So in the research study, when some groups receive treatment and the other groups are receiving placebo, which is a fake treatment. If alpha is 1%, can you support the claim, that's the claim, that the reduction rate in the diagnostic criteria for PTSD is higher for those who took the medication than those who took the placebo? So we want to see that if the reduction rate, the rate means the proportion, is higher in groups that receive treatment compared to the group that received placebo. So we have the information from the two. Okay, after reading the problem, first you need to check the requirement. Like any other hypothesis, we need to check the requirement. But for checking the requirement, we need the pooled estimate as well. So we need to find P bar, which is x1 plus x2 over n1 plus n2. And we need to find Q bar, which is 1 minus P bar. After finding the P bar and Q bar, we need to make sure that the samples are random We need to make sure the samples are independent, which they are because they are two groups of people. And we need to make sure that N1 times P bar, N times time Q bar, N2 times P bar, and N2 times Q bar, all of them are more than 5. Now we made sure that the problem meets all the requirements, so we can start writing the null and alternative hypothesis and following other steps to complete the full hypothesis test. To write the null and alternative hypothesis, I need to look at the claim. The claim says that the reduction rate in the diagnostic criteria for PTSD is higher for those who took the medication, that means group 1, than those who took the placebo, group 2. So you know that they are talking about the rate, the proportion. So when you're writing the null and alternative hypothesis, again, you will have P1 and P2. And since we have a higher rate for those who took medication, that means P1 must be greater than P2. And it goes on the alternative, and we make sure that's a claim. And if alternative is greater than, that means the null is less than or equal to. Then we need to find the critical value and the rejection region. And based on the alternative, which is greater than, I need one critical value, and the area to the right is my rejection. And I know alpha is 1%, so that means this area on the right is 1%. If I want to look at the Z table to find the critical value, I need to have the area on the left. If the area on the right is 0.01, the area on the left is 0.99. So when you open the Z table, you need to look at the body of the Z table and look for 0.99 to find the critical value. So now let's look at 0.99, which is, is over here. And you see that the critical value is 2.33. So the critical value is 2.33, and since we have a right tail test, the rejection region is any Z value which is more than 2.33. After finding the critical value, now it's time to write the formula and find the test statistic. And after finding the test statistic, we see that the Z value must be 3004, which is more than 2.33. If test statistic is more than 2.33, that means it's in the rejection region. And if it's in the rejection region, and you will see that's in the shaded area, you need to reject the null. And if you reject the null, let's go back to if you reject the null, that means you can support the claim. And the claim is on the alternative. I am going to use the word support, so I have enough evidence to support the claim because I'm rejecting the null. So we say there is enough evidence at 1% level of significance to support the claim that the reduction rate in the diagnostic criteria for PTSD is higher for those who took medication than those who took placebo. And the last question, he says, an economist believes that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. So that's a claim. I always underline the claim because when I'm writing the null and alternative hypothesis, I need this. The economist obtains a random sample of 800 urban households to find that 338 of them have internet access. So the first sample size is 800, and the number of success, or X1, is 338. The economist obtains a random sample of 750 rural households and found that 292 of them have internet access. So the first sample size is 750, and the number of success for the second sample is 292. Test economists claim at 1% level of significance. Alpha is at 5%, sorry, at 5% level of significance. Okay. Whenever they give you N1 and X1, you need to find P hat 1 and P hat 2. That's the first step, because P hat is always X over N. And 338 divided by 800. So P hat 1 is equal to 0.42. If I round it to 2 decimal digits. And if I have P hat 1, I can find Q hat 1 as well, which is 0.58. We do the same for the second sample, P hat 2, which is X2 over N2. And 292 divided by 750 is rounded to 2 decimal digits, is 0.39. And if P hat is 0.39, Q hat is 0.61. For checking the requirement, we also need the pool distance. We need to find P bar and Q bar as well. P bar is X1 plus X2 over N1 plus N2. X bar is 338 plus X2, which is 292, divided by N1 plus N2. And the answer is 0.41. I am rounding all the decimals to 2 decimal digits. And Q bar, which is 1 minus P bar, and 1 minus 0.41 is 0.59. Okay, now after finding all this information, I am going to start the hypothesis test by checking the requirement. The requirement tells me that the samples must be random. Yes, they are, because it's mentioned here. Samples must be independent. Again, they are, because they are from 2 different areas, urban households and the rural households. And also, we have to have at least 5 success or 5 failures. That means X values must be more than 5. They are more than 5. Or you can multiply N1 by P bar, N1 by Q bar, N2 by P bar, and N2 by Q bar to make sure that all of them are more than 5. You can do that steps on your own, just using your calculator. Then I need to write the null and alternative hypothesis. To write the null and alternative hypothesis, I'm looking at the claim. So the claim says that the percentage or the proportion of the urban, that means the first sample, is greater than P1 is greater than P2. And that's my claim. And you know, whenever we don't have equal sign, we put it for the alternative, because the null should have the equal sign. And if the alternative is greater than, the null must be less than or equal to. After writing the null and alternative hypotheses, by looking at the alternative, I know that I have the right tail test because it's greater than. So I need to find the critical value, and the area to the right is my rejection region. And I know that the alpha is 0.05, which is the area on the right. But if I want to look at the z table to find the area, to find the critical value, I need the area to the left. If the area to the right is 5%, the area to the left is 0.95, is 95%. So I look at the z table. What is the z value for 0.95? Let's find 0.95 in the body of the table. It's somewhere between these two. It's almost between these two values. And the first value is 1.64, 1.65, and the number in the between of these two is 1.645. So my critical value is 1.645. That means that the rejection region is any z value that's greater than, because the shaded area is on the right, greater than 1.645. After finding the rejection region, I need to write the formula and plug in numbers. So I need to erase some part of the board to have more space. Let's see, what can I do? So just write P bar, which is 0.41, and Q bar, which is 0.59. Now I can erase these parts. Write the formula. What is the formula? The formula says that P hat 1 minus P hat 2 minus P1 minus P2 over the square root of P bar, Q bar, 1 over N1 plus 1 over N2. P hat 1, 0.42, minus P hat 2, which is 0.39, minus P1 minus P2 is always 0 because we always assume that the P1 and the P2 are the same. And on the denominator, we have a square root of P bar, 0.41, Q bar, 0.59, 1 over N1 plus 1 over N2. And if I put this one in calculator and find the z-value, it will give me 1.33. And after finding this test statistic, you are going to check if the test statistic falls in the rejection region. Rejection region tells me that the number must be more than 1.645 to be rejected. But the number that I got is 1.33, is not more than 1.645. So it's not in the rejection region. If it's not in the rejection region, you fail to reject a null. If you fail to reject a null, that means you reject the alternative. If you reject the alternative, that means you reject the claim, so you don't have enough evidence to support the claim. So the answer is there is not enough evidence at 5% significance level to support the claim that the higher percentage of urban households have internet access compared to the rural household. Now let's see how we can use online calculator to answer this question. If I open online calculator, I need calculator number 19, which is two proportion. If I open the calculator, it will ask me about the first and second sample, the sample sizes and the number of success. Sample size means n, number of success means x. So the first sample size was 800. The second sample size was 750. The number of success in the first sample was 338 and 292. 338 and 292. Now I need to choose, make sure to select the correct notation here, because if you don't, you may get completely different answer. And this depends on the claim. If you look at the claim says greater than. Greater, so I need to choose greater than. And I also need to choose the confidence level, and the confidence level is 1 minus the significance level. If alpha is 5%, the significance level is 0.95. So alpha is 5%, yes. Okay. So you can always select not pulled. Okay, for this part, always select not pulled. And let's see what do we get. And if you calculate, you'll see that the test statistic or the z-value is 1.3298. And if you round it to two decimal digit, it gives you 1.33. And we got 1.33 as well. And this is going to give you the p-value as well. If the question asks you about the p-value, you can use this value. When we are using the z-test, we can find the p-value manually as well if you don't want to use a calculator. But anytime you are using t-test, you need the calculators to find the p-value. Okay? How we can find how we can find the p-value manually. If you want to find the p-value manually, you need to find the test statistic first. Okay, after finding the test statistic 1.33, then you need to show 1.33 as a z-value, and the area to the right should be your p-value. That means if you look at the z-table and find 1.33, is, this is the area. You know that's the area to the left. Okay, so that the area to the left is to remember 0.9082. 0.9082. And if you need the p-value, which is the area to the right, you need to subtract this number from 1. And if you subtract this number from 1, it gives you the p-value. So when we have z-test, it's easy to find the p-value manually as well. But you still can use online calculators for working on your homework and exams and the whole semester.